So in these next few videos, we are going to investigate some mathematical expressions that speak to gases, particularly their pressures, volumes, temperature, and amount. These laws, collectively called the gas laws, can be subdivided into these four main categories. The first being Boyle's law, named after Robert Boyle, famous scientist. And with Boyle's law, that expression speaks to the fact that the volume of a gas at a constant temperature is inversely proportional to the pressure. That means if your volume of gas decreases, the pressure increases. Or if you increase the pressure of a volume of a particular gas, its volume increases. So that expression or that observation can be put into a mathematical expression that is known as P1V1 equals P2V2, where if you have some initial pressure of a gas with an initial volume, if you change the pressure of that gas to some final value, that volume will also change as an inversely proportional relationship. So P1V1, initial pressure times initial volume, is equal to P2V2, final pressure times final volume. And so that simple expression, Boyle's law, can be used to solve problems such as this one. So let's say we have a gas with a particular volume at a particular pressure. And I want to know the new volume of that gas if the pressure is increased, assuming constant temperature. So looking at what's being given, I see I have an initial volume and I have an initial pressure. I want to know what my new volume is, V2, given some new pressure, P2. So using Boyle's law, P1V1 equals P2V2 is going to be the equation that we use. But hopefully you've noticed that, the pressure data that is given to you, those are in two different units. And to solve this equation, Boyle's law for volume, and have my units cancel appropriately, both of my pressures need to be in the same unit. And so it really doesn't matter which unit you convert as long as they are both in the same pressure unit. So I went ahead and I converted my pressure from millimeters of mercury to atmospheres, because that's a unit of pressure we're going to need to use with the ideal gas law that we'll talk about in another video. So I have my initial volume, I have my initial pressure, which I have converted into atmospheres using the conversion factor between millimeters of mercury and atmospheres. I have my final pressure, I need my final volume. So I take Boyle's law and I solve it for V2 by dividing both sides by P2, which I will do messily here, but do more neatly down here. Doing that and substituting in the appropriate values, I see my units cancel. I'm left with milliliters, which is great. That's a unit of volume. That's what I'm looking for. And so doing that multiplication and division should give you a final answer of 7.25 milliliters. And that makes sense. That answer makes sense based upon Boyle's law. We said that volume and pressure of gas are inversely proportional. In this sample, we increased the pressure, so we would expect our final volume to decrease or be less than the initial volume, which it is. And so that's a good way that you can kind of double check yourself to make sure that the answer that you get from the problem is correct. So that's Boyle's law involving pressure and volume. The next video is going to talk about volume and temperature of a gas.